Hello. Let's see here. Hello. It's working. It's working. Okay, I finally, well, this was still mistake filled, but less mistake filled. So I'm kind of happy with how this one turned out. I'm actually gonna flip this. We're gonna start off by flipping a few things. This stream is gonna be like super duper short. I only have like a few things I want to change. But I figured I'd show you guys what I did after I ended yesterday's thingy-majig. So I basically added this really stupid mess of LED blinking and, oops, what the heck. Anyway, I added this little mess here. It does a little chime on startup, make sure the computer's working all right and everything's running the way it should. I did get the tower clause working correctly. That segment is down, nested under countdown here. Just this short little if statement saying, you know, if I'm at 3 seconds, we're gonna write the servo position to be that. And then, you know, after ignition, we're gonna move that servo, tower clamp servo full. I'm actually gonna change this to be more like that long because I wanna make sure that the rocket has plenty of time to leave the pad before that sucker closes. And then I'm also going to, let's see, we're gonna change the delay for the MOSFET ignition, but yeah, so let's start off and let's see how that looks. If ignition delay servo. So let's do, that seems like a really long time to me. It's high for half a second, then it writes it to low. I'm not sure why I put 2 delays in here. That's kind of silly. So let's just do like this in 200. And then the other thing I wanted to do is I wanted to fix the reset button. The reset button is not really working. So right here, I believe void reset is what I'm looking for. So switch digit to be J. You know what else is weird? The computer does not keep, and I think it's because I put this break command in there, but the computer does not, like, when I hit 0, it resets the time on the clock to what I started with. So if I started with 15, it sets it back to 15. If I started with 10, it sets it back to 10. And it keeps all the servos still like in their locked position, like after they've been released. So I don't know what that's all about, but we're gonna have to kind of go through here and figure that out real quick. But yeah, like really this doesn't have that much left. And then I also want to open Aurora's code. So this guy, we'll explain this sucker real quick too. So a couple of libraries. This is for the IMU. There's several libraries for this. This one actually worked better for some reason than the other library I started off with. I think it was just MPU6050.h. For some reason this worked a lot better. The other one was causing me a lot of issues. This is basically importing a PID, general PID loop library. This is for writing on wires. This is for servos, obviously. This is for the onboard data logging SD card. This is a library that deals with optimizing storage on that SD card. This is just defining where different servos are attached. So 2 for the TVC, 1 for the parachute release. This is defining their name. This is just writing to the MPU and assigning a timer. This is for the pad idle system, which basically the rocket doesn't gimbal or do anything until it detects an acceleration on the IMU, and it will start thrust vectoring. This is timers and stuff that deal with pad idle timer. Let's see. Servo moved. I don't remember what that was for. Oh, this might have to do with homing the TVC mount when we turn it on. These are my very important PID loop values. This is just a bunch of set points, setting everything initially. So this is what we're starting with. This is, let's see, set point x0 times xptr. I don't remember what this does. It's been a while. This is declaring two separate PID loops for the X and Y. Might not be the best way to do it, but that's how we're doing it. This is the pin for the SD card. Chip select. This is literally all the void setup right here, I think. So just defining stuff. This is making sure the SD card is in the slot, otherwise it won't let me use the rocket. Serial. This is my baud rate. This is freeing the memory. Let's see, the output limits. This is setting the output limits of the TVC mount, because I've explained that earlier, how mechanically it's allowed to move in one axis more than the other. This is a sample time to make sure that the computer doesn't crash. And I don't know why I was doing that. Set mode, I forget what that does. This is a timer. This is calling the MPU to start reading data. This basically is homing it. Log data timer. So this is testing to, or this is writing. This is basically where we're logging. This is how we're logging the data. We're writing it to the SD card. This is all the values we're recording on the SD card. So the time, angles recorded, and the outputs on the servos. Boolean check pad idle. That's just making sure the rocket is on the pad, or if it's not. And this is what I need to change actually. So let's do like 1.25 or something. This is the parachute delay. This is the loop. We're basically updating our MPU, outputting our PID values. This, for some reason, is not recording. I think this needs to be underneath. Oh, because it's a serial print. Duh. Well, I have this kind of not being used right now, but I'm going to actually change it so that we're writing acceleration probably to the SD card. I think that's a good idea. If this is basically the update frequency of the data logging, so we don't want to crash the computer again because we're using a crappy Arduino, so that's going to prevent things from crashing. So we're going to verify that, and then I will upload it and test it on the rocket. Alright, so let's go underneath here. So what we're going to do now that I made those couple of updates is we're going to test it on the pad after I upload it, and then I'm going to figure out this void reset thing, or I mean, geez, the reset button code, because for some reason it's like half working but also not, so I don't really know, but we'll figure it out. Let's see, do we have anybody watching? Let's check the chat. Nope. That's alright, this is meant to be a resource for later reference. So, hold on. Hold on. What was I looking for? Oh, I know. I'm gonna go figure this out here. So we want to have that reset button to work, and it isn't right now. So let's see, boom. Hold on a moment. What would I see to add? So hold on a minute. We're gonna figure out why the heck this isn't working. Void reset. Clamp one. Okay, so this should be. Let's see. 9999. I'm confused what is happening. Into digits, countdown. We're looking for reset. Alright, so. Oh, I forgot to have dark mode on the computer. Darn it. Light number, digital, digit. So how much of this is the same and how much has changed? So digit read button 3 low. Oh. Gosh, I hate coding. I'm confused why 14 countdown finished. Do nothing. Okay, so let's go down here. We're in our while loop. And then do I have... So here. I don't know. Oh, yeah, so basically this is for the ignition. This actually, I really could have done this in an easier manner, but right here, you can see countdown finish. So basically, there's a program above where it recognizes if the clock has reached 0 and compares that and says, oh, if we are at 0 and we realize that, see this exclamation part, this exclamation mark, this not here, that means not. So if countdown's finished and ignition is not complete, then we're going to fire the MOSFET igniter, and that loop or that program is down here. You can see it's sending a signal to the MOSFET pin for half a second, then turning it off. Right here, actually we'll keep this, and I'll just turn it down a lot. And then basically, once we fire it, we're going to say ignition is now true. So this boolean is now false. If for some reason this fails to complete, it would return false and run through that program again. Let's see. So if we go down here and we say while countdown is finished, and this would all be, let's see, and is equal to high. I'm trying to think here, like what the heck I want to do on how I'm gonna like figure this out, because I want to be able to use the reset button. Let's see, button, we have, let's go up and figure out what's going on with the buttons. It's equal to 1. If ignition is true. this statement isn't true. I don't know. Well, it's partially true, but not true. So this is kind of a stupid segment, to be honest, because this is just saying when the value of button 2 is equal to 1, then you would run through this loop, I think. So, and then if ignition is true, then it would run through this segment, because all of this is nested underneath this command. So technically, well, it's not a terrible idea, because if this evaluates to false, then it won't release the rocket. So that is what we want. But I feel like this value is kind of a, or this like while loop is kind of a stupid way of doing it. I don't know. Let's see, fire, sorry. I'm looking for, see, if ignition complete. Okay, you know what? Here's what we'll do. We're going to add a segment. I'm going to add a segment here where it's if it recognizes if the ignition, oh my god, what is happening to my computer? If ignition is complete, right, we're going to actually move the servos up a little bit. So this would be, hold on, 90, so 0. Yeah, this would move them up a tad. And actually, let's do 45. I feel like that's a smarter value than this. So let's do like 45, not 405. And we're going to write all 4 servos to be like right here. So clamp servo 2. And what I'm going to do is basically after what do I have these? These are set to 0. Void servo. I actually don't. No, this doesn't make sense. No. Let's do this. While countdown is finished, and let's see. Where's the and sign? Like, oh, it's 7th, duh. And countdown is finished. Okay, I want to figure out the button situation, because I feel like I could be doing something better. So let's figure out button 1, 13, 12. Oh, I'm wondering. Oh boy, and I actually don't remember. So 13, if I look at my computer, it's what, 17, 16, 12, and 13. So this, yeah, this should be button 1. I don't know. I've done this a really stupid way, to be honest. But yeah, that should be button 1. That's equal to low. So if I haven't pressed the start button, then I feel like this is not a good... What did I just do? Let's go down here and let's see. Let's go. Let's see. Ignition. Reset. I'm looking for reset. Oh shoot, where did I start typing that? Yeah. Let's move this into... Let's move this sucker to the reset. Read button 1 is equal to low. Okay, int m 0 is pressed. Int digits pressed forward. Oh my gosh. Let's try, digital button. Okay, which button is button 1? So while button 1 is equal to low, so while the start button isn't pressed, run through this code, I think. Oh no, wait, this wouldn't work because this would just... Can I just do... Can I just do an if statement? Can I just go like, if digital read button 3, so that would be, or no, button 2, because that's reset, equals high, then yep. And then, yep. So let's do void startup check. Let's do this as like a little segment, and then let's go back down to void reset. Oh, you know what? Let's do this. I know what I'm gonna do. All right, you ready, guys? Check this out. If button 2 is equal to high, and actually we'll do countdown finish because we're not gonna need to reset. We're not gonna need to reset until it's already been counted down, I guess if that makes sense. So if countdown is finished and the reset button has been, oh my gosh, has been pressed, then we'll run through this segment. So this segment, what it's doing is it's going to do the startup check, which I just enclosed above. Then it's going to write all of my servos. It's going to write all my servos to home position. And then if I do this as well, it's going to write everything to the home position. And then we would want to do display digit. Okay, display digit. What was that function that was in Countdown earlier? It was like display digit, I think. Countdown, int, print number. So let's try that. So countdown. Or actually, you know what? Let's see. Here's what we'll do. We're gonna go down here. And we're gonna make it print the initial countdown time when I press reset. And then under here, I think this is my problem. So we're going to take a look at this later, but I think that's my problem. Is this break command is like causing the reset button to be overridden. That's what I think that break command is doing. Because I think what break does is it like stops everything on the computer. So we're gonna take care of that, and probably do another live stream after I eat dinner. So look into. Startup check. Uh-oh. Let's do that. That work? No. Oh, this is in void setup. Can I even? Huh. You know, maybe I don't need to do that. because, let's see, digital read. Oops. Duh. Alright, we'll figure this out after dinner. See y'all later.